guys, welcome to question FM348 of the Further Maths Fortify study guide. This question reads, an outdoor tent manufacturing company is changing from square-based pyramid tents to tetrahedron tents. Assume that the new tetrahedron tent will use an equilateral triangle for its base. The height of the square-based pyramid is 1.5 meters and the side length is 1.6 meters. So we can see it in here, as shown in the figure below. The volume and height of the tents will remain the same before and after the change. So we're going to have an equal volume between these two tents and they have the same height, which means that we have different dimensions. Well, some of the dimensions are different at least. Question A says, what is the volume of the square-based pyramid in cubic meters? Round your answer to 2 decimal places. So we're being asked to find the volume of this pyramid on the left, the square-based pyramid, which we can do by using the formula for the volume of a pyramid, which is 1/3 times the area of the base times height. So substituting our known values in here, we get 1/3 times, now the area of the base, since this is a square, is just going to be 1.6 by 1.6, or 1.6 squared, and the height, we've been told, is 1.5 meters. Whacking all of that into a calculator, we should get an answer of 1.28 meters cubed for the volume of that square-based tent. Part B then says, what is the area of the base of the tetrahedron tent? Round your answer to 2 decimal places. So funnily enough, we're actually going to use the same the same formula once again. So we're going to have the volume of the pyramid is going to be equal to 1/3 times the area of the base times the height. Now we know that the volume of our tetrahedron tent is going to be the same as our volume for our square-based pyramid. So we're going to take this 1.28 that we found before, and we're going to make that equal to 1/3 times, now this area of the base, that's our unknown, maybe we call that x, and we're going to times that by a height of 1.5 meters. At this point you can use solve. You've set up an equation that has one unknown, so you solve for our unknown x, or if you're wanting to do it by hand, you can show the rearrangement by hand. I would recommend using solve in an exam type scenario because they're not going to, solve doesn't get it wrong. And you don't actually have to write down that you're solving. Your next step for writing it down would just be x equals and then whatever you found x to be. So in this case, solving for x should give us 2.56 meters squared for the area of that base. Finally, question C says, what is the side length S of the base of the tetrahedron tent? Round your answer to 2 decimal places. Now there's a couple of ways that we could figure this out. We could insert values into Heron's formula and sort of use those S's to create different values. But we're going to take a slightly, I think, easier approach. We know that we've got an equilateral triangle, which means each angle is going to be 60 degrees. We also know that the side lengths on either side of that angle are S and S, so we can use a slightly easier area formula for a triangle and just have that our area is going to be equal to half times A times B times sine theta. So plugging in our known information, we've got half times, and we have S times S, so we're going to say S squared times sine of 60 degrees. And we also know that this area is going to be the area that we found before. So this area is going to be 2.56, which means once again, whacking this into solve, we can solve for S, and we should come out with S equals 2.43 meters. Now, when you solve for S in this scenario, you may also get a negative value for this length. Of course, you can't have a negative length unless it's sort of relative to something else and there being a positive direction. But for what we're looking at, we only want the positive value. So there you have it. There's those 3 questions. If you guys have any questions for us, please leave them in the comments below. Otherwise, I will see you in the next video.